Hi, my name is James Laxton, and I work for Famsun. And in this presentation today, I'm going to going through a little bit about optimizing energy efficiency in your Aquafeed drying. So a little about me. I've been working in the industry about 18 years, all dedicated to design and commissioning, project management, things like that, in drying. I worked for Bueller Aeroglide for 10 years, and I've been with Famsun about 8.5 now. So as I said, I've been doing product design, field commissioning, application work. I've done all types of different dryers for all types of different feed and food. So the way to optimize energy efficiency in aquafeed drying is to first learn how this energy efficiency should be calculated. So that's the first thing we'll go over. So is your dryer consuming too much energy? The dryer is one of the largest consumers of energy in the process line. So that means that if you're using too much energy in your dryer, you're probably using too much energy overall. So that's one of the key aspects of really controlling your energy efficiency and energy expenditures. So what is energy efficiency? So it's your target efficiency divided by your actual energy used. So it's the use of your energy to perform work and how well you're doing it. This should be one of the main goals for the operator of any production line. Of course, product output is probably number one, but maintaining energy efficient production line is a close second. So in order to calculate this energy efficiency, between production runs, it's important to always use the same metric because you're not always using the same input parameters for each production rate. You could have different recipes, different rates, different machines, so it's a good metric to always kind of have that energy efficiency and a percentage, just so it kind of compares everything on the same plane. So in order to do that, we're going to need some basic factors. You're going to need to know your evaporative load. You're going to need to know your natural gas flow, your energy consumption, your fuel efficiency, and the theoretical energy required to remove 1 kilogram of water. So let's go over some of this stuff and kind of define it a little more. Your evaporative load is the most critical factor because that's where you're actually doing the work. So you're removing that water, how much water you're removing. And all your other parameters should be set according to this to the spec. And it's basically just found by taking your dryer output minusing your extruder output, and that gives how much water you've removed. So next we need to know your natural gas flow or steam if you're using a steam dryer. This is taken directly from a flow meter in a gas or steam system. Your energy consumption rate is going to kind of vary by region. It's a constant factor, but it's based on the type of fuel you're going to be using in that region, and they can vary slightly depending on where you're located. So that's going to be the formula for that would be your energy consumption rate multiplied by your natural gas flow will give you your energy consumption rate. So next you'll need your fuel efficiency of the water removed. It's calculated by the following formula: your ER, your energy consumption rate, divided by your evaporative load equals your fuel efficiency. That's just pretty straightforward. Then your last number you're going to need is your theoretical energy to remove 1 kilogram of water. So this is a constant. This doesn't vary. This should always be what you're using as a constant. This is just what it is in physics to remove that much water. So now that we have all those defined, we can put it into practice. We know the formula needed to do this. So what we're really trying to get at is your fuel efficiency, and that will, divided that your theoretical efficiency divided by your fuel efficiency is going to give you that energy efficiency percentage. So in this data chart you can see here, we've defined, this is just a production run of a 3 millimeter floating feed. And all of these things are defined as shown here. And you plug it in to the calculations I showed previously, and you come out with your energy efficiency number, in this case being 88.2%. So that's the metric you want to use across the board for all different production rates, product types. That's going to give you the best baseline for comparing different dryers, different plants, different runs, all those things. So you can use that efficiency. So let's talk about what the operational factors that are going to impact your energy efficiency are. So there's two types of operating variables. One is your dependent variable, which the dryer in drying really has no control over. It just has to deal with them. And then you've got your independent variables, which are what you can control within the dryer. So all your parameter settings that you're going to have. So dependent variable, obviously you can't control that. So you got your production rate, incoming production rates, your product characteristics, density and size of the product, your incoming moisture, outgoing moisture. Those are the targets you're going to extrude your output target, and then you got your dryer output target. So those are just what your incoming and outgoing. Then your environment air conditions. This is just what you have to seasonally adjust to. And that's really just, you can do that, energy audits, you can do those on a dryer to somewhat control, kind of adapt to that environmental condition, but it's really just something you have to adapt to constantly because it can change the whole aspect of how you're drying. So we'll look a little bit at the independent variables that you can change. So you can see you've got your exhaust air and the settings you can have with that. You've got fan speeds, and you've got your production level and retention time in your bed. And of course, the largest one would be temperatures, which is what actually is taking most of your energy up. So processing temperature, like I said, is going to be your largest consumer of that energy. And that's really what, adjusting these temperatures can have a really large impact on your energy consumption overall. And if you maintain these temperatures, you will have a nicely efficient dryer. But if you have any loss in these temperatures, you're going to really have an inefficiency. So next, you'll have fan speeds that you can control. You've got your recirculation fans, you've got your exhaust fans. These should always be set according to your testing or your product recipe that's in production at that point. If you have a large difference in what products your 8 millimeter floating pellet versus a 1.2 millimeter sinking pellet, you're going to have a lot different fan speeds you're going to need to set for those two different types of products. So too much or too little can have extremely negative effects. And we can, as shown here, if you have these fans, your recirculation fans, in this case, turned up too high, you can get your product entrained in the airstream, and it's just going to kind of follow that air around the dryer, and it'll end up collecting in points where it's really hard to get to clean out. So you'll have to shut down production and get in there and clean it out. So this is something you really don't want to do. So it's critically important to keep those air speeds down so that you don't have this happen. And that is also directly impacting on what kind of product you're drying. So you need to be aware of that as well. So if these aren't followed correctly, you can the recipe settings not followed correctly, you can get a lot of product build up all over the dryer, really. So your product depth and retention time, this really is just, you're going to adapt to the incoming production rate and production type, of course. The incoming production rate is going to determine the required retention time you're going to need. And that's going to determine your product depth. So that time equals depth, really, based on what production rate you have constantly coming in. So as we said previously, the fan speeds need to be set according to that. And this just kind of shows if you have too much, if you're using, a sinking pellet, small sinking pellet, you still got your fans turned up from a large floating pellet, you can get that lift off the bed. And that's not good. That's when you're going to get your product distributed throughout the dryer. That's never a good thing, which can cause some energy inefficiencies and also, shut down for cleaning or maintenance. So the last one here is exhaust air volume. And this is a very critical parameter setting for the efficiency in the drying process. Too much hot air will cause, of course, if you exhaust too much hot air, you're going to have to reheat that cold air coming in at that same volume. So it can really increase the amount of energy you're using. On the flip side of that, if you're exhausting too little hot air, you'll leave too much moisture in the product, and you're not going to get a dry product. So you'll have to, scrap that product or remill it. So the dampers also play a factor in that how much air you're letting out or coming into the dryer. That's really more and can have some balancing issues. So very small adjustments in the dampers can have a maximum, large impact on your energy savings. You always want to try and recycle the exact right amount of air. I know it's hard to do that, but to really look at an optimal amount and take good measurements and do testing and have those presets already predetermined, so you know what's going to happen, and you're recycling the optimal amount of heat. So we know the main consumer of the energy is going to be just heating the air in general, but also in this case, reheating that air that's coming in. And that exhaust fan is going to regulate how much, the volume of that air. And if you are exhausting, excessive amounts, you're going to create a very inefficient dryer. So in this case, we'll look at two different setups here, both doing the same evaporation rate. You can see dryer 1 and dryer 2. Dryer 1 is setting at 100 degrees, dryer 2 at 120. And the exhaust rate is really what's changed here, along with the relative humidity. The exhaust rate of dryer 1 will be 15,000 cubic meters per hour. Dryer 2, 10,000 cubic meters per hour. But you can see that because you're exhausting less, you can turn that heat up more and use a hotter environment to dry this process. And you actually end up using less, even though you're at a higher temperature, because you're exhausting less. So this will be the winner in this scenario. And as I said, when you're exhausting less air volume, less cold air is going to be reheated, making the dryer more efficient. So when the exhaust air volume is reduced, recirculated air is more saturated and can cause uneven drying. So you need to compensate for this by heating the air up more, so that it can hold more water. So balancing the dryer is another very critical component. I mentioned it earlier, and just the environmental impacts, yearly. In some regions, you have a wet and a dry season. You really need to go, balance your dryer to make sure you're optimizing the efficiency in doing that. So you can set your dampers accordingly. And you want it balanced so you're not over pressurizing the dryer. You don't want hot. If you open the indoor, you don't want the air just hitting you in the face and blasting out. You get dust and everything just coming right at you. You really want to kind of have a small negative draw, but you don't want it to be so much of a negative, from the indoors that it's, you can't even open the door. You don't want to suction, shut even if it's unlatched. You want to be able to access it and just have a kind of a slight draw where it's not pushing anything back out at you, really. So another way of balancing the dryer is by using the psychometric tests. Your dry bulb versus wet bulb, using your psychometric chart. And this is a very, very good way to really fine tune the balance of your dryer. So you're operating at a maximum efficiency. You're only exhausting, you've got everything set correctly, and you are exhausting exactly the right amount of air. So another one is your product distribution. You want to really maintain, it's really critical to maintain an even distribution on that bed, because the way you put it down in the beginning is the way it's going to go through the dryer. And any deviation in that evenness or in that product spread level, air is going to find the path of least resistance. So it's going to kind of exploit any drop or gap you may have in your feeding process. So it's going to, and as it goes through the dryer, each zone is going to kind of exploit that more and more. And by the end, you're not going to have a very even dry product. So how can we improve energy efficiency? Well, the first thing you have to look at is losses. So all dryers are going to have some losses. You're going to have, just based on the external air exposure to the machine itself, internal and external temperature variation, how well insulated the entire dryer is. And your typical loss is around 3% of the total heat in an Aquafeed dryer. This is the goal of any design of any dryer, should be to really minimize those losses as much as possible. Another way is using a recipe management system. And that really makes for a stable drying curve, where you can just, click a button and it knows exactly what it needs to be doing for each preset recipe, and it just comes in and goes out, and you're up and running quickly, and you're producing at maximum energy efficiencies. So as I said, having this preset recipe management system, it does a lot of great things for you. Minimizing waste is a huge one, but really staying consistent, not having huge deviations from operator to operator is a really key thing. And obviously rapid startup, you can change recipes, start it right up, click a button, here we go, and you're off. And just always knowing you're gonna have that consistency, and knowing things shouldn't change from there. So it'll also have some physical benefits, where you're not going to get your pellets in the airstream or distributed throughout the dryer. You're going to keep a fairly clean dryer inside as much as you can. You won't make any of those pellets or debris airborne. So knowing that in a lower bed depth, small pellet, and the fans automatically change based on that recipe preset is really, really imperative to making your final moisture targets achieved. So we can also use the humidity control system. This is a more advanced system where you're gonna have software that's gonna modulate your exhaust fan and your dampers to really have an automated solution to exhausting exactly the right amount of air volume. So it'll use your dry bulb, wet bulb, right in the control panel, and it'll speed up or slow down that exhaust fan and modulate the dampers as well. Another way is using a heat recovery system. Famsun has developed a new dryer recovery device. It was first used in the market in 2018, and we've had great success with it with our customers. So, as we know, a typical dryer will have multiple heat zones, where you'll have more moisture removed in the first few zones than you will the last few. So in this case, we can in this case here, there's nothing to recapture that heat in the last zones to reuse it in any way. So if we put the heat recovery system on, we can kind of grab that heat that's being lost to the environment otherwise and reuse it in previous zones, which makes less work for the heating systems, and results in a much more energy efficient system. So it can significantly reduce that energy and in turn save money. And I always like to say that if you keep a clean dryer and just have a cleaning schedule that you can maintain, I'd say once every 4 weeks at least. I like to see it every 2 weeks, but just keeping heat exchangers and filters as clean as possible really will go a long way in improving your lifelong energy efficiency. Just not having that build up keeps it short and sweet cleaning cycles, and you know what you're getting every time. So just my recommendation is keep it clean, and you can create a great energy efficient dryer. So thank you very much, and I hope presentation was helpful.